I'm going to try to integrate this expression here. Now it's a product, so we're probably going to need integration by parts. We use integration by parts when we have a product and when it isn't clear whether one expression is the derivative of the other. So the derivative of ln x isn't square root of x, and neither is that. That substitution probably wouldn't work. So we use integration by parts. So the formula for integration by parts is the integration of u dv equals uv minus the integral of v du. So that's the formula. You're generally given that in the exam. So what we need to do is choose u and dv correctly. So this is the way I would do it. Let's get this out of the way. I'll put it up here. So we have u and du, and then dv and v. So we're going to put these two here and here. Now the general rule is you choose dv to be something that you're able to integrate. So whatever you put here, you need to be able to integrate it. So we're going to integrate dv to find v. And whatever we put here, we need to be able to differentiate it. So this is d by dx. So if I were to put ln x here, how would I integrate it? We don't know the integral of the natural logarithm, so that's not a good choice. So you would choose ln here because we know how to differentiate it. The derivative of ln is just 1 over x. And that leaves this to be put there. So we have square root of x, and then you integrate square root of x. Now I can write square root of x as x to the power half. So that becomes x to the power 3 over 2 divided by 3 over 2. When you divide by a fraction, it's like multiplying by the reciprocal. So I'll just write it as 2 over 3 times x to the power 3 over 2. Now we're going to apply the formula for integration by parts. So here it is. Oops. It's uv minus the integral of v du. So let me write it out. So the integral of square root of x ln x dx equals uv, so that's this times this. What I sometimes do is draw a big capital letter N, so it's this multiplied by that. So I'll write it out as 2 over 3 x to the power 3 over 2 times ln x minus the integral of v du. So it's the product of these two. So it's minus the integral of 2 over 3 x to the power 3 over 2 times 1 over x dx. So it looks like we've taken this and made it more complicated. But actually, this isn't an integral, so that's okay. And this, if you look at it, it can easily be simplified. So we can write this as 2 over 3 x to the 3 over 2 ln x minus the integral. Now if we put that in the denominator and this in the numerator, what we have is easily simplified, because when you divide, you subtract powers. Let me remind you that x to the power m divided by x to the power n is x to the power m minus n. So keeping that in mind, I can subtract 1 from 3 over 2. That will give me x to the power 3 over 2 minus 1, which is a half. So that becomes x to the power half. I can put that in there, and it now becomes a much easier integration, because the integral of x to the power half is simply x to the power half plus 1 divided by half plus 1. So now we're one step closer to our final answer. So it's 2 over 3 x to the power 3 over 2 ln x minus the integral. Well, let's leave the 2 over 3. X to the power half becomes x to the power half plus 1 divided by half plus 1 plus c. And that's now really easy to simplify, because half plus 1 is 3 over 2. So we've got, you're going to divide by 3 over 2, so that's like multiplying by 2 over 3. So this is just that. And then you multiply by x to the power 3 over 2. In your final step, you're going to multiply 2 by 2 and 3 by 3, and that will give you 4 over 9. So you can just write 4 over 9. And that's your final answer. So that's how you would integrate an expression like that using integration by parts. So the important thing here was applying the formula and choosing your u and dv correctly. So I chose u to be the natural logarithm because I know how to differentiate it. Whereas if I had chosen dv to be ln x, I wouldn't know how to integrate it. There isn't an easy integral for ln. So always choose ln as u so that you can differentiate it. And that's the formula for integration by parts. So I hope you found that helpful.